right, an outcome is the result of a single trial. You don't need to memorize that or anything like that. Just giving you some terminology. Shh. All right, an outcome is the result of a single trial. So, for example, if I flip a coin, what are the two possible outcomes? Heads or tails, okay? A sample space is all the possible outcomes. It's technically the set of all the possible outcomes, but I'm trying to reduce the amount of writing you have to do. All right, and an event is just one or more outcome. So you could say, what is the probability of getting 2 heads? So in that question, your event is getting 2 heads, okay, when you're flipping a coin. All right, if something is independent, do you think one event affects the other event or does not affect it if they're independent? Does not, okay? Does not affect the other event. Okay. Once again, flipping a coin is independent. If you flip a coin and get tails the first time, does that affect whether you'll get tails the second time? Nope, it doesn't. 50-50 every time. All right, dependent is where the outcome of one event affects the outcome of another event. An example of that is if I have a jar with blue and green marbles, and I pull out a green marble, and then I put the green marble on my desk. When I go to draw the second marble, does that matter that I put the first one on my desk and not back in the bag? Yes, because I've changed the number of marbles in the bag. So that would be a dependent event. Okay. All right. There's 2 ways to do these visually. You can do a tree diagram, or mathematically, you can use the fundamental counting principle. Again, it's just a math word, but you don't need to memorize it. You just need to know how to do the problem. Fundamental counting principle. All right, I think the definition is extremely hard to understand, but I'm going to give it to you anyways. Again, all I care about is can you work the problems. But the definition says, if event M can occur in M ways, and is followed by event N that can occur in N ways, then event M followed by event N can occur in M times N ways. Again, please don't try to understand that if that made no sense to you. Just know how to do the problems. Okay, here's a problem. A sandwich vendor offers a choice of hamburger, chicken, or fish on plain or sesame seed bun. How many different types of sandwiches are there to choose from? So, you get to choose your meat. What else do you get to choose? Your bread. Yes. Okay. How many choices of meat do you have? 3. What are they? Good. Or fish. So you got 3 of them. How many choices of bread do you have? 2. What are they? Plain and sesame. According to the fundamental counting principle, you're going to multiply your choices. So 3 times 2 is 6. So there are 6 different sandwiches. Okay? You don't need to write this next part. I just want to prove this to you with a visual. So I can choose a hamburger, chicken, or fish. If I chose the hamburger, I could then choose to put the hamburger on plain or sesame. If I chose chicken, I could choose plain or sesame. If I chose fish, I could do plain or sesame. How many different? 6. Okay? All right. B, Kim won a contest on a radio station. The prize was a restaurant gift certificate to one of the city's 3 best restaurants and tickets to the following sporting events: football, baseball, basketball, or hockey. How many different ways can she select a prize? So, how many different ways can she select her prize? What is her prize made up of? A restaurant gift certificate. All right, so a restaurant gift certificate, or what else does her prize consist of? A sporting event. Okay, so she gets to choose from a restaurant and a sporting event. How many choices does she have for the restaurant? 3. It says that right here. 3 restaurants. How many sporting events? 4. Football, baseball, basketball, and hockey. And what do you do with those 2 numbers? Multiply them. So there's 12 different ways she could pick her prize. Okay. All right, many answer machines allow owners to call home and get their messages by entering a 3-digit code. Think about that like your PIN on your debit card or something. How many codes are possible? So it's a 3-digit code, so I'm going to do 3 blanks. Anybody know how many digits there are to choose from for that first blank? 10, because you can use 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you are including just numbers. So there's 10 digits to choose from. How many are there for the second blank? 10, because your passcode could be 000. Okay, what about for the last one? 10. Okay. What do you do with those 3 numbers? Multiply. What does that give you? 1,000. So there's 1,000 different codes. 1,000 different codes. Anybody need more time to write? Any questions? Okay. Charlene wants to take 6 different classes next year, assuming that each class is offered each period. How many different schedules could she have? So how many blanks should there be? 6. So there are 6 periods, which it's not clear. It should be clear. So I apologize that this question's a little hazy. So there's 6 different periods. There's first period, second period, third period, fourth period, fifth period, and sixth period. Okay? Again, this question could be a little clearer. How many choices does she have for first period? 6. She's got 6 choices. Okay? Now, once she chooses her first period class, how many choices does she have for second period? 5. Because she can't take advanced functions first and second period. Okay? All right, what about for third period? 4, because now she's already chosen 2, so there's only 4 left. What about for this one? 3, and then 2, and then 6th period, she's got whatever class is left on the list. Okay? All right, does anybody, what are we doing with those numbers? Multiplying them. Anybody already have that answer? 720. So that's how many different possible schedules she could have. Different schedules. Okay? All right, B, a computer's 6-character password can be formed if the first 2 characters are letters and the remaining characters are digits where both types of characters can't be repeated. How many possible passwords could there be? Mariah, how many blanks should I do for this one? 6. I'm doing a 6-character password. 1, 2, 3, 4, 5, 6. Keelan, what does it tell you about the first 2 characters? They're letters. Guys, how many letters are in the alphabet? 26. Now, it also tells you that they can't be repeated. So that just depends on the problem. Sometimes the problem will say they can be repeated. Sometimes the problem will say they can't. So you got to read it. That's something to definitely underline. Can't be repeated. So she's got 26 letters for the first blank, but if it can't be repeated, how many choices for the second one? 25. Okay. All right. Tanner, what does it say about the last 4 characters? They're digits. So again, what do we say? How many possible digits are there? 10. But those can't be repeated either. So after you have 10 choices for this one, but if they can't be repeated, it knocks it down to 9 and then 8 and 7. Okay. Anybody got that one? Very good. Okay. All right, C, how many different 5-digit passcodes are possible if the first digit cannot be 0 and the rest of the digits after the first can be used more than once? Keith, how many blanks for this one? 5. Gracie, what did they tell you about the first blank? It can't be 0, so how many choices do you have, Gracie? 9. The first digit cannot be 0, so you're only left with 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right, now the rest of them can be 0. All right, and they can be used more than once. So this one is what? 10, and this one is 10, 10, and 10. What are we doing with those numbers? Multiplying them. What is it? Okay, this is a word that you do need to know. All right, the word permutation is a group of objects or people in a certain order. All right, a group of objects or people in a certain order. That's what's called a permutation, if they are in order, in a certain order. So some keywords to look for that indicate it's a permutation, if they say they're arranging them or placing them. All right, that puts it in a certain order. So will somebody read the example for us? Good. So for a batting lineup, is there a certain order? Yes, so that's why it's a permutation. Okay. In the calculator, it's going to be NPR is the key that we're going to use, and I'll show you where that is. P stands for permutation, and your N is always going to be the bigger number. All right, the first number will always be the bigger number. Okay, sometimes there are problems where there's repetition, and that one has this formula, which makes no sense until we actually do an example. Oops, this should be a P. So just write it down, but it'll make a lot more sense when we do an example. So math just got exciting. There's some exclamation points there. I know. It'll make sense when we do a problem. We're not there yet. We're right there. That goes there. Oh. Okay. Guys, if you want to, you can draw like a squiggly line because there's not one on your paper, because this is all dealing with permutations, all this stuff. Okay. And then right after this is combination. Okay. So combination is the other word that you do need to know. A combination is a group of objects or people not in order. All right. Not in order. All right, so words that indicate a combination to kind of help you know which one is which. So if you see the word select or choose, 99% of the time that's going to be a combination. Will somebody read that example for us? Good. Does it matter what order they choose their two toppings in? No. Okay. All right. In the calculator, this one is NCR. C stands for combination, and once again, N is the bigger number. Okay. All right, Paige, read A for us. Okay, so I'm awarding medals. Does it matter? So I'm picking how many people to get medals? How many people am I picking to get medals? I'm picking 3 people. They're going to get gold, silver, and bronze. Does it matter what order I pick them in? Yes, because first place gets gold, second place gets silver, third place gets bronze. So order matters. Okay, I'm not going to write this for everyone. I'm just trying to introduce this new concept to you. So order matters. Okay, so if order matters, is that a permutation or combination? So I'll put a P for permutation. That's what it stands for. How many total people are there? 10. That's your bigger number. It goes in front. 10. And how many people am I picking? 3. Okay. In your calculator, the first thing you type in is 10. In your calculator, you type in a 10. Then you hit the math button. And you go over to PRB. That stands for probability. That's the name of this chapter. Go over to PRB. And you're going down to number 2. P stands for permutation. That's what problem this is, a permutation problem. And then you need to type in the 3. And the calculator tells you there are 720 ways to award the medals. Okay? Anybody's calculator not working? All right. B, Jeremy is selecting 3 of 15 flavors of ice cream. How many possibilities are there? Okay, he's selecting 3 flavors. Does it matter what order he puts them in? No. So order does not matter. Order doesn't matter. You don't need to write this. I just want to give a visual to people who are visual learners. Order doesn't matter. So is that a permutation or a combination? Okay, so this one's got a C. How many total flavors are there? 15. That goes in front. How many is he choosing? 3. So in my calculator, I type in a 15. What do you think I hit next? Math. Over to PRB. And this one I go down to number 3. And then type in another 3. And there are 455 different ways he can get his ice cream. Okay. All right, C, a teacher divides his class into 8 groups for a project. He will choose 4 groups to present their projects. And how many different ways can he choose the presentations? So, guys, here's why this is a key word. Choose the presentations. It's not saying how many different ways can he arrange them, like pick who goes first, who goes second, who goes third. All he's doing right now is choosing the 4 groups who are going to have to give that dreaded presentation. Okay? So does order matter? No. When it says choose, 99% of the time order doesn't matter. Okay? So Olivia, is that a P or a C? A C. And Paige, what number goes in front? 8, because there are 8 groups. And Paige, what number goes in back? 4, because he's choosing 4 things. All right, anybody got that answer? 70. Okay. All right, D, how many different ways can 5 members of a club's Ranked committee that has 9 members be placed on stage. Anthony, does order matter? Guys, please don't answer for other people. Order does matter because you're placing them on stage. Okay, so think about having chairs on a stage. You're going to assign seats. Okay, who sits where. Anthony, what number goes in front? 9. And what number goes in back? 5. Okay, anybody got that one? Okay, before we go on to the next one, let me point out something real quick. None of these had repetitions in them. None of them had repetitions. You can't pick the same person to win gold and silver. Can't be repeated. This one, he couldn't pick the same flavor twice, the way the problem was worded. This one, you wouldn't choose a group to present, the same group to present twice. This one, you can't have one person sit in 2 seats on the stage. Okay, so none of these had repetition. All right, now this next one has repetition. Anytime it's asking you to do letters, chances are there'll be repetition. Not always, but chances are. So this one has repetition. So we have to use the exclamation point formula. All right. So how many letters are there in the word Mississippi? 11. So on top you put 11 exclamation point. So that was for the total letters. Then I'm going to divide it by the letters that repeat. So what's one letter that repeats? S. How many S's are there? So you put 4 exclamation point. That's for the S's that repeat. Okay. What other letter repeats? The I. How many I's are there? 4. So you put 4 exclamation point. That's for the I's that repeat. Is there any other letter that repeats? The P. How many of those are there? 2. So I put 2 exclamation point, and that's a P. Okay. All right. In my calculator, you want to type in 11. Everybody do this, please. Type in 11. Hit the math button. Go over to probability, PRB, and then you'll see the exclamation point as number 4. Divided by, what do you think would be a good idea to put around the bottom? Parentheses. So a parenthesis, 4. Hit the math button again. Exclamation point, 4, exclamation point, and 2 exclamation point. You should get 34,650. Anybody's calculator not working? Good. Okay. Number or F, the manager of a 4-screen movie theater is deciding which of 12 available movies to show. How many ways can he arrange the movies on the screen? Jacob, does order matter or not? Yes. So arrange indicates the order matters. He's picking which one gets the first movie screen, the next movie screen, the third movie screen, and so on. Samantha, what number goes in front? And the number in the back? 4. It's a 4-screen movie theater, so sometimes you have to go back and read. All right, anybody got that one? Good. Okay. G, Abby is trying to choose 9 books out of a list of 12 from a reading list. How many options can she have? So I know she's going to read them in a certain order, but that's not what the question's asking. All she's doing right now is choosing them. She's just choosing the 9. She's not choosing what order to read them in right now. She's just having to tell her teacher, I want to read these 9 books. That's all she's doing right now. So Hope, is this one a C or a P? A C. All right, Chase, what are the 2 numbers for this one? Good. Okay. Yeah, always. All right, what do we got for this one, y'all? 220. Okay. All right, H. How many different ways can Johnny place an algebra book, a geometry book, a chemistry book, an English book, and a health book on a shelf? Chase, is this one a P or a C? Yep. So if you're placing them on a shelf, once you put the first book on, it's going to matter. There's just going to be an order. When you put something on a shelf, it ends up in an order. Okay. Caitlin, how many books do I have total? Caitlin's not here. Charlie, how many books do I have total? 5. And guys, how many am I putting on a shelf? Sometimes that happens. That's okay. 5P5. What you got? Yep. Questions? Okay. All right. You will draw winners from a total of 25 tickets in a raffle. The first ticket wins 100. The second ticket wins 50. The third ticket wins $10. How many different ways can you draw the 3 winning tickets? Let me have Cole. A P or a C? A P. Guys, why is this one a P? What does first place get? $100. So would you care if you were third place? What's third place only getting? 10. Okay, so the order matters on this one. You want to be first place. You care what order it's in. Okay. Jose, what's my first number? That's how much money they're getting. 25. There's 25 tickets. And Jose, how many tickets get picked? 3. Okay. What y'all got for this one? Okay. Jay, how many different ways can the word company be arranged? Okay, so I know this one is letters, but does company have any repeats? No. So this one you could do 2 different ways. Okay. Since it is a word, you could still use the exclamation point formula. How many total letters are there? 7. But there's no repeat, so you wouldn't divide it by anything. So that's one way you could get your answer, just 7 exclamation point. Okay? Yep. Okay? The other way you could do it is if you're arranging these letters, does order matter? Yes, so that's a P. How many total letters are there? 7. How many are you arranging? 7. These both give you the same answer, so either way you want to do it. What you got? All right. Okay, you have 20 songs on your iPhone. You have time to listen to 3 of the songs. And how many ways can you choose the 3 songs? Once again, I know when you actually go to listen to them, they're going to be in a certain order. But right now, it's not asking that. Right now, it just says you're choosing the 3 songs. Okay, so you can tell somebody, hey, I want to listen to these 3 songs. Okay, so is this one, does order matter? No, you're just choosing them. So it's just C. Okay. Austin, what number goes in front? And what number goes in back? Anybody got that one? And the last one. A principal is starting a mentoring group. He needs to narrow his choice of students to 6 from a group of 9. How many ways can he choose a group? Kirsten, is this one a C or a P? And Kayla, what are my 2 numbers? Good. $84.